we know that the integral from a to b from f of x dx is f of x from a to b. So this is f of b, the antiderivative evaluated b, minus the antiderivative evaluated a. I did not mention last time, but you have to remember that this must be continuous on the interval a comma b. Otherwise, we get into improper integrals and other issues that are dealt with in Calc 2. So that's one requirement. Second thing, there are properties of the definite integral. Properties of the definite integral. And there are several properties. Okay, ready? Here is one. The integral from a to a of f of x dx. 0. There is no area between a and a. Is that clear? Property number 2. The integral from a to b from f of x dx, this is not apparent, is the opposite of the integral from b to a from f of x dx. Third property. The integral from a to c f of x dx is the sum of two integrals from a to b from f of x dx plus the integral from b to c from f of x dx. Let me explain the third property. Let's take a look at the picture here, figure. Here it is. So I have c here, I'm sorry. This is c. So this integral, this, represents this area that I shaded in. If I break this somewhere, anywhere I want, let's say here, that's my b, then obviously this is the first piece and this is the second piece. I should have showed just a straight line. So the integral from a to c is the sum of two integrals. The integral from a to b plus the integral from b to c. Any questions? Okay. Next property. Property 4. The integral from a to b from f of x plus g of x dx. What do you think this equals to? And also we can write the one with minus.
Integral from a to b f of x plus dx plus integral of a to b.
Very good. And of course, if we have a difference, this will be the difference. Property 5. The integral from a to b from a constant times f of x dx. Exactly what happened to the summation notation or to the limit notation or operand. The integral from a to b from f of x dx. C is a constant. The same thing we did with the limit operator and with the summation notation. Any questions? There are some comparison properties, but I would like to practice this for a moment, and then we'll go back to the comparison properties. Problem 47, 48, 49, 50 on page 384. Let's say we start with 47, where we have the integral from -2 to 2 from f of x dx plus the integral from 2 to 3, no, to 5, I'm sorry, to 5 from f of x dx minus the integral from -2 to -1 from f of x dx. Write as a single integral in the form the integral from a to b of f of x dx. So we're looking at a function that is definitely continuous, otherwise we don't even discuss it. Continuous on the interval between -2, so there is -1, -2, 1, 2, 3, 4, 5. So here's the function, f of x. So the integral from -2 to 2 is this area. The integral from 2 to 5 is definitely this area. So when we're asked to add these two, we will have the integral from -2 to 5 from f of x dx. But now they want us to subtract the integral from -2 to -1 from f of x dx. So what will you write as the final answer? Can anyone give us the answer? So I'm giving you from -2 to 5, and then I come back and say, give me back the -2 to -1. What are you left with?
So, I mean, I guess weird.
You're left with the interval from.
Oh,
Just
oh,
add it.
oh, oh, okay, so that's an interval from -1 to -2. Well, if you're just swapping it around, right?
Okay, one more time.
Oh,
-2 to 2 is this area, and I'm giving it to you. I'm also giving you the area between 2 and 5. Now you have the area between -2 and -5, and then I'm telling you, give me back the area between -1 and -2 and -1. What are you left with?
-1 to -5, right?
What do you?
Sorry, to +5.
Correct.
Rest at -5.
From f of x
Rest
dx.
at dx.
Is that clear? We see it? Okay, let's do it again. So the area between -2 and 2 is this area, in red. The integral between 2 and 5 is this red area in purple. So by adding these two, we have all the area between -2 and 5. Is that okay? But then I subtract. I take away the area between -2 and -1. That's why I erased it. So then we are left with -1 to 5. Is that okay? Good. Problem 50. That's okay. Yes, after 1 hour of sleep, I'm surprised you can walk. The integral from 0 to 3, maybe you want to go home. If f of x is 3 for x less than 3, and it's x for x greater than or equal to 3. So I'm asked now to find the area between 0 and 3 knowing that f of x is 3 for x less than 3, and it's x for x greater than or equal to 3. Can anyone dictate what I should write for the integral from 0 to 3 from f of x dx? Based on one of the properties that we just mentioned.
Well, for all of f of x, you're going to be integrating the first function of f of x is equal to 3.
Yes. Did I copy? I could have copied. Yes, I copied incorrectly. Thank you. Thank you.
5 of Eric.
Obviously, he's awake, and I can see. So now you can rephrase. I give you time. So obviously, I have to break it up in the middle, right? 0 to 3 plus 3 to 5. There is no other way, because less than 3 is something, and beyond 3 is something else, and the interval is 0 to 5. So I will have to write from 0 to 3 of what?
0 to 3 of 3.
3, not 3, but 3 dx. Remember, base times height. Good. So then from 3 to 5, x dx. Very good. How do I determine the integral from 0 to 3 from 3? What is the antiderivative of 3?
3.
No. What function prime is 3?
3x.
3x. From 0 to 3. Plus, what function prime is x?
X squared over 2.
From 3 to 5. So let's do this. I plug in 3, what do I get? Subtract when I plug in 0, but when I plug in 0, I get, so I don't have to bother with that. Please leave the number outside, which is the constant 1/2, and only plug in 5, 25, minus when you plug in 3, which is 9. You can deal with the constant later. Do not put it in. It's easier if you subtract and then deal with 1/2. So this is 9. 25 minus 9 is 16. 16 divided by 2 is 8. So the answer is 17. Any questions? Okay, here is problem 41. It says evaluate the integral from pi to pi from sine squared x times cosine to the 4th x dx. Of course, there is no area between pi and pi of any function. Very good. I would like to determine 40, which is the integral from 0 to 10 from the absolute value of x minus 5 dx. How do I handle this?
You break it into partial.
Into two functions, exactly. So I have to write that the absolute value of x minus 5, as we know from a long time ago in pre-calculus, this looks like what and or what?
X
Minus 5 if x minus 5 is greater than or equal to 0, which means x greater than or equal to 5, or
negative
x plus 5 if x is less than 5. So therefore, like before, a few minutes ago, I have a sum of two integrals. It's one of the properties. So from here, have the integral from 0 to 5 plus the integral from, 5 to 10. And from 0 to 5 is?
from 0 to 5 negative
X plus 5 dx. And from 5 to 10?
x minus 5.
Very good. So let's calculate this. Now the antiderivative of negative x plus 5. The antiderivative of negative x. Which function prime is negative x?
X negative x squared over 2.
Plus, which function prime is 5?
5
5x, and from 0 to 5, plus minus from 5 to 10. As we know, we have to plug in 5 first. Negative 25 over 2 plus 25, but luckily when I plug in 0, what happens? 0 minus 0 plus. I plug in 10, 100 over 2 is 50, minus 50, minus, put it in parentheses to make sure that you don't make a mistake. When I plug in 5, I get 25 over 2 and minus 25. Any questions so far? Any questions so far? Okay. So, these two go away. Negative 25 over 2 minus 25 over 2 is minus 50 over 2, which is minus 25. And then 25 plus 25 and plus 25, yes.
So when you get a half of the 25, and you subtract.
Yes, I have negative 50 divided by 2, which is negative 25.
Then you get negative 25 over 2, but that's times the minus, right? So then that becomes a plus. And
No, it's negative 25. Negative 25 over 2 minus 25 over 2 is negative 50 over 2, which is negative 25. Then I copied this 25, and then I copied this 25.
Oh.
That's okay. That's okay. That's okay. That's okay. Is that okay? No, I don't want you to. Now it's too late. Okay, any questions on this? Okay, now let's look at a couple of comparison properties of the integral. And maybe we look at an example. Okay. So comparison properties. There are 3 that I would like to mention. Of the definite integral. The definite integral has limits of integration. The indefinite integral will not have limits of integration. The definite integral is always a number. The indefinite is always a function. Ready? If we know that f of x, that's the first property, if the f of x is greater than or equal to 0 on the interval a comma b, what do you think will be the integral from f of x dx b? Yes, it will definitely be greater than or equal to 0. Absolutely. If the function is a positive function, the area will be positive. Now let me show you an example. Here's an example. Obviously, this area between 0 and 3 will be negative or positive because the area under the graph is bigger than the area above the graph. Okay? Good. Comparison property number 2. So assuming I have a situation in which a function f of x is always above a function g of x on the interval a comma b. So a situation like this, for example, on the interval a comma b, one function is here and another function is here. Can I say that f of x on the interval a comma b, I don't care about outside, but on the interval a comma b, f of x is definitely greater than g of x on the interval a comma b? Very good. No, it's above. But you can say it's more area, exactly, because that's the conclusion. Exactly. You're way ahead of me. I love it. So then, what will you say about the area from f of x dx from a to b, and the area from g of x dx from a to b? Exactly what you just said. It has to be greater than. It's more area under f because it's above g. And the third one, let's suppose I have this situation. where m and m are positive numbers. Or just numbers. But this is the order, which means a scenario of this kind. Let's say this is m. Let's say this is m, of course, on the interval a comma b. Here's the interval a comma b. And I have this function, which is f of x. Knowing that this is the interval a comma b, can I write this relationship on the interval a comma b? That the function is between m and m? Good. So then, if that's the case, I'm allowed to integrate all three sides of the inequality for the interval or on the interval a comma b. So the left-hand side is the integral from a to b from little m dx. The integral has no meaning if you don't have a dx or dy or dz, but d, right? It must be less than or equal to the integral from a to b from f of x dx, which must be less than or equal to the integral from a to b from uppercase m dx. Do you agree with this? This is based on what we just discussed a minute ago. Good. So now I cannot determine this in the middle. I cannot. But I can determine these two. I take the constant outside. And what is the integral of 1 dx? What function prime is 1? X is from a to b, less than or equal to the integral from a to b from f of x dx. And what do I have on at the other end? M, from mx, the integral from a to b. But I know how to finish up the left-hand side, how to find this. What is it? In x, I plug in b, and then I subtract when I plug in a. So it's m in parentheses b minus a, less than or equal to a to b from f of x dx. M, b minus a. It's the area of the rectangle, of course. So the area of this rectangle and the area of this rectangle. So of course the area under the graph is bigger than the area of the bottom rectangle, but it's larger, but it's smaller than the area of the big rectangle. So now one more thing, and then we look at examples. Does anyone remember what an odd function means? Can anyone give us an example of an odd function?
An odd function has degree.
No, an odd function is symmetric with respect to the origin.
Okay.
So here is an odd function, x to the third, symmetric with respect to the origin. And let's suppose, and this is crucial, the interval is symmetric. When we talk about the origin, when we talk about a symmetric interval about the origin, we mean between -3 and 3, or between -5 and 5, or between -10 and 10, and so on and so forth. So I will say between -a and a. What do you think the integral from -a to a from f of x dx will be when the function is odd? 0. Do you all agree? This area will be exactly that area, but one is positive and one is negative. Let's calculate it right now to convince ourselves. The integral, let's say, from -2 to 2 from x to the third dx. What do you expect this to be? The function is odd, the interval is symmetric. What do you expect the answer to be? I expect the answer to be 0. So let's do that. What function prime is x to the third? Over 4. From -2 to 2. Leave 1/4 outside because it's a factor. Plug in 2, you get 16. Minus, plug in -2, you still get 16 because -2 to the fourth is positive. But minus comes from the fundamental theorem of calculus, right? I have to have minus. So when I plug in 2, minus when I plug in -2. So the answer is 0 as expected. Now, can anyone give us an example of an even function?
X squared.
Very good, excellent. So here's x squared. The same idea is this is an even function and it's x squared. So let's say the same thing, negative a to a. The integral from negative a to a from f of x dx, where f of x is an even function, will equal twice, very good, the integral from 0 to a from f of x dx. So because whatever this area is will equal this, and it's easier to calculate twice the area from 0 to a than to calculate the area from negative a to a. Since the function is even, the answer will not be 0. Any questions? Any questions for me? Okay. Let's work on problems now. Back to the same page. I would like to look at problem 57. I see it in, it's marked in red. Let's take a look. Two less than or equal to the integral from negative 1 to 1 from the square root of 1 plus x squared dx less than or equal to 2 the square root of 2. It says, use the properties of the integrals to, of course, of definite integrals, to verify the inequality without evaluating the integral. We cannot even evaluate the integral. Okay. I have to start with the function. And I know that x is between negative 1 and 1. Okay, so this is where my starting point is. I write x between negative 1 and 1. Is that clear? Because I have the lower limit negative 1 and the upper limit 1. So this must be between x between negative 1 and 1. Okay. Now, look at the function. The function has x squared, has 1, and has the square root. Okay, so obviously I have to create this portion first. How do I create this portion? What should I do to all three sides? Or I should say this. If x is between negative 1 and 1, what should x squared be? Between what and what? So imagine a number between negative 1 and 1. And if you square any number between negative 1 and 1, what will be the smallest number you get? 0. And what is the largest number you get possible? 1. So this must be between 0 and 1. Also, if you remember, look at x squared. Between negative 1 and 1, if you square any number between negative 1 and 1, you will get anywhere between 0 and 1 as the y value. So if x is between negative 1 and 1, would you agree that x squared must be between 0 and 1? Okay, so I created this piece. I'm closer. What do I need to do now to all three sides to create this piece? Add 1. I'm adding 1 to the left. I'm adding 1 in the middle. And I'm adding 1 on the right-hand side. But now I want to create this. Since all three sides are positive, how do I create this in the middle? Well, I cannot just create it in the middle. I have to take the square root from all three sides. And that will be okay, because the function is increasing. So the square root of this, the square root of this, and the square root of this. So 1 less than or equal to the square root of 1 plus x squared less than or equal to the square root of 2. Now we had the last property that we talked about before the odd and even functions. And we said, if I have a function between lower m and upper m, I can integrate all three sides, and I will get the integral from negative 1 to 1 dx, negative 1 to 1 dx, negative 1 to 1 dx. So I have the middle part that I'm interested in. What is the integral of 1? from negative 1 to 1. What is the integral of the square root of 2? The square root of 2 multiplied by x from negative 1 to 1. Let us know if you can drive home tonight, because we are concerned. You should text me later. Okay, so when I plug in 1 minus when I plug in negative 1, what do I get on the left? Careful. When I plug in 1 minus when I plug in negative 1. Exactly. Less than or equal to. When I plug in 1 minus when I plug in negative 1. So 2, and that's what we're asked to do. Any questions? Any questions? This is another nice chart that shows positive areas and negative areas. Positive areas and negative areas. Any questions? I would like to work on problems on page 394. Anything you want from 19 through 44. I would like to choose at least 4 problems. I'll let you choose. And I'll put my attendance in. If no one has a book, then I will choose. Okay, that's fine. I will choose. That's okay. So 26, the integral from negative 5 to 5 from e dx. 32, the integral from 0 to pi over 4 from secant theta tangent theta d theta. Problem 40, the integral from 1 to 2, 4 plus u squared over u cubed du. So let's start with these 3. I'll put my attendance. we have an answer for the first one? Do we need more time for the first one? Okay, so E is a constant. So we take it outside. So this is the integral from -5 to 5 dx. And 1 is an even function. You can say it's twice from 0 to 5 if you want to, but you don't have to. So anyway, so it's Ex from -5 to 5. It's E, leave the constant outside. We plug in 5 minus -5, so that is 10. So this is 10E. We're working on the second one, 32. Do we need more time on the second one? Do we have the answer?
So the cosine of power of 4, that's a square root of 2 over 2.
So secant theta, tangent theta. Which function prime is secant tangent? From 0 to pi over 4. So this will be secant pi over 4 minus secant 0. Secant is 1 over, if it starts with S, is 1 over cosine. Very good. So then this is 1 over cosine, which will be cosine of pi over 4 is the one that is the same. Sine and cosine. The square root of 2 over 2. So 1 over the square root of 2 over 2 minus 1 over secant 0 is, yes, secant is measured on the, cosine is measured on the x-axis. 1 over 1. So this is 2 over the square root of 2 minus 1. You can rationalize the denominator. 2 the square root of 2 over 2 minus 1, and you will simplify. So it's the square root of 2 minus 1. You can leave it alone. Now, can anyone tell us what to do with number 40? Think for a moment.
Pull out 1 over u.
No, I can do that. I cannot pull out variables. I can only pull out constants. So can anyone tell us or give us a hint on number 40?
Break it into 2.
Exactly. No, break it into 2 fractions. 4 over u cubed, which is 4 times u to the -3, plus u squared over u cubed, which is 1 over u, which you cannot bring into that form. Okay. Now what? What function prime is 4u to -3? 4 u to -2 over -2 from 1 to 2 plus. Which function prime is 1 over u?
Natural log.
Yes, natural log of the absolute value of u from 1 to 2. Excellent. Now the first one, I simplify 4 and -2, and I get -2. Leave that alone. And then you have u to -2, which is 1 over u squared. So it's 1 over 4 minus 1 plus. I plug in 2. I get natural log 2. I plug in 1, and I get 0. So 1/4 minus 1 is -3/4. So -2 multiplied by -3/4 plus natural log 2. I will simplify, and I get 3/2 plus natural log 2. I need to practice more on this. We want to practice more, correct? Okay, let's choose Any questions on this problem? Is this okay? Let's look at 39. I'm going to copy a few. The integral from 1 over the square root of 3 to the square root of 3 from 8 over 1 plus x squared dx. That's one problem. Then 43. The integral from 0 to pi from f of x dx, where f of x is given to us as sine x